Okay, so
Did you
Doctor.
get the part where I said NIH 7120025?
Okay, according to the U.S. Special Virus Cancer Program, go ahead and say it, Z.
Dr. Robert Gallo isolated the HIV enzyme in accordance with Special Virus Program contract number NIH 712025.
Okay, so he isolated what they call the HIV enzyme. See, but this is what they tell you. They say the U.S. Special Virus Cancer Program was supposed to find the cause and the cure of cancer. Did it do that? No. This is why no doctor in the U.S. today can tell you anything about the Special Virus Cancer Program, because they did not research cancer. It was not a cancer research. Proof of this was the development of a virus called what? The
ESP-1 virus.
The ESP-1 virus. What does the ESP-1 virus have to do with cancer research? It was a six-sided microplasm.
Biological ages.
Okay. Now, something else they discovered in the 1960s. I'll give you guys a bonus on this one if you guys get this right. They discovered something called the CCR5 Delta 32 positive. Who can tell me what that is?
It's a code to the docking station on each cell. So they can target black people, specific cells.
Okay, so if I wanted to target just a strictly African person, what is a docking station I would need to target that?
And then, so to ambush the body, you can use gene splicing to put a different virus into a known virus's shell to ambush the human body.
Okay, and what Zeke's doing is he's going way above you guys. He's educating you guys on some real stuff, because not only can we prove AIDS is an agenda, we can show you how they make it. So I want you guys to watch at the end of the venue. We're going to bring in Dr. Chi. He will show you how they make HIV, or not HIV, or what we call AIDS. Okay, because AIDS is not a virus. It's a what? Agenda. It's not a specific virus. So what did they need in 1980? Because look, they couldn't walk around infecting everybody with a hepatitis B vaccine. What did they need? What was John D. Rockefeller's ultimate plan? How can he spread this? How can he convince you that there is a new terror, there's a new war, and the war was AIDS? He created a war. Thus the war, people started protecting themselves. Children stopped being born. You know, if you do the research from AIDS, as soon as AIDS arrived, there was a decrease in African American birth. There was a decrease in cervical cancer an increase in cervical cancer for women. There was an increase in abortion. There was all across the U.S. where you go is safe sex, safe sex. Safe sex, more condoms, more condoms. Really what they're saying is no birth, no birth. Depopulate, depopulate. This is their codes, and they're going to scare you by telling you that there's this terrorist out there called AIDS, that if you get him, he's going to kill you. Let's prove this.
We're talking about HIV/AIDS. There are two viruses that are associated with the development of this retrovirus. And when scientists first discovered HIV, so-called discovered, they called it a cancer virus because it was a T-cell attacker. And that's how you got all of these so-called retroviruses. But the primary viruses that are associated with HIV/AIDS are two. One is called a sheep visna virus. And I'll put this right here for you. Sheep visna virus. Sheep visna virus is associated with Nazi Germany. Hitler did a lot of work with this virus to develop a biological agent to use against the Allied forces and to use against the Jewish peoples of Germany. So he did a lot of preliminary work with sheep visna virus. It is a virus that is common in sheep, causes sickness similar to pneumonia. So when an HIV patient, for example, comes down with this virus or disease, they usually have a symptom like pneumonia, fluid in the lungs, discharge. Sheep visna virus causes this in sheep, okay? Not in human beings, but in sheep. The other virus that is associated with HIV/AIDS is bovine leukemia virus. Bovine leukemia virus. Bovine leukemia virus is a virus that is often found in cattle. Many of your dairy farmers have to deal with bovine leukemia virus. And what separates bovine leukemia virus from sheep Visna virus is, number one, bovine leukemia virus only affects cattle. But bovine leukemia is a cancer virus because it is a T cell attacker. So it attacks your T cells. And your T cells are what allow you to have your so-called immunity. If you get an infection or if you get a cut on your hand, the T cells rush to that area to gobble up the foreign invader or the so-called foreign invader. The T cells are your first line of defense for your immunity. So if you knock out a person's T cells, you knock out their ability to fight off infection. So that's why bovine leukemia virus is a so-called retrovirus and considered a cancer virus because it is a T cell attacker. All right? So let's move forward. So we know that sheep Visna virus and bovine leukemia virus are the two components that we're looking at when we study HIV. Now, something peculiar about the sheep Visna virus, and I put the abbreviations here. This is sheep Visna virus and bovine leukemia virus. These are the abbreviations. So how do I take these viruses that infect sheep and the other that infects cattle to get those to infect a human being? This is a very complicated process, and in the laboratory we use things like DNA ligase. We use all kinds of reagents to help us cut apart certain DNA and RNA of viruses and then recombine them to create new ones. This is done all the time. It's done with bacteria. In typical science nomenclature, they call this recombinant DNA technology, recombination. One way to do this, and I'll take you through both ways, but one way to do this is to take sheep Visna virus and bovine leukemia virus and somehow combine them. Now, remember in science there's something that is called a species barrier, meaning that there's certain viruses that can't cross over from another animal to a new animal. That's called the species barrier. So these viruses are locked and have to abide by that law of the species barrier. That's why if you take sheep Visna virus and infect me with the sheep Visna virus, I will not come down with symptoms of sheep Visna virus. If you take bovine leukemia virus and inject it into me, I will not come down with the symptoms for it because my body does not recognize these viruses. And in order for a virus to infect the body has to recognize it at the molecular level. So, how do we get this to get inside of the human being? Well, one way to do it, as I said, we take a cat. And I'm going to draw my little cat here. Don't laugh at my cat. Here's a little kitty cat. Put a little tail on him. Looks more like a rat, huh? All right, so this is a cat. So what we do, we take sheep Visna virus and bovine leukemia virus, and we inject the sheep Visna virus into the cat, and then we inject the bovine leukemia virus into the cat. And by doing this, what we are trying to create is allow the sheep Visna virus and the bovine leukemia virus to break apart in the sheep's body, in the cat's body, and then recombine in the cat's body. So I want some of the DNA from sheep Visna, and I want some of the DNA from bovine leukemia virus to break apart and recombine inside of this cat. And this happens quite often whenever you take a virus and put it into a human being or put it into an animal. The body's own defense mechanisms and the body's own processes will break apart that virus and then recombine that virus in new forms. So that's what I'm trying to do. So we'll go to the next step here. We have this cat here, and the kitty cat. We have infected the cat with sheep virus and Visna virus. With some whiskers, right? So sheep Visna virus is in here, bovine leukemia virus is in here, and the cat's own body has recombined different aspects of these viruses into one new virus. So now I want to extract the new combinant or the new recombinant virus out of the cat. So you extract that out of the cat and you get it in blood serum, right? So in your blood serum, now you have a newly formed virus, which is now bovine Visna virus, or bovine Visna virus. This is what you got now because the cat recombined the other two viruses into one new virus. Now this is a whole new virus. If you can see that, it's a whole new virus. So let's move forward. So how do you take this virus now and infect it into human beings? So that's one way to create this bovine Visna virus. Let me write this again. Bovine Visna. I spelled it wrong. Visna virus. Okay? So the bovine Visna virus, you have extracted this out of the cat because you allowed the sheep Visna virus and the bovine leukemia virus to recombine. So now you have a T-cell attacker, right? Because remember, the bovine leukemia is a T-cell attacker and Visna virus all in one. Okay? So now we have a human being. Remember I said that you cannot cross over the species barrier because certain diseases will only affect animals and others will infect human beings? Well, now we got this bovine Visna virus, which is a T-cell attacker, and if you just infect this into a human being as it is, as I said earlier, it will not present symptoms of bovine Visna virus. In other words, if bovine Visna virus is a T-cell attacker, and I take this and put it directly into a human being, it will not cause any sickness in the human being. And they've done the same studies with monkeys as well. If you take AIDS and put it into a monkey, it really should cause disease, since we are, what, 98%, yeah, I think it's 98% of our DNA is in common with the monkey. So you should be able to get AIDS to take in a monkey, but you can't, because you have to cloak these bovine Visna virus in the shell in order to get it to attack human beings. So we got bovine Visna virus in this little protein coat, because it's a virus, and we want to make this infect a human being. But if we give bovine Visna virus to this human being, it won't take. And we don't want to give them something else. We want to give them AIDS. So if you want to give a person AIDS, you got to get this bovine Visna virus to get inside of that human being. The way that this is done in the laboratory, we have to give the body something that it is familiar with. And certain viruses, the body will not accept them. When I say the body will not accept them, I'm saying that there are receptors that are on the surface of cells that viruses.
Yeah, I'm about to go in. Yeah. Let's get it. This is the manuscript. My lyrics are catastrophic. Punchlines and metaphors leave you stiff like catatonics. Your thoughts are microscopic.